All right, so here we go. So we're working through the homework, 3.1. So don't do that online 3.1 section. I'm going to yank that off the system. Don't work on that. I'm doing this instead. This will be due to physically hand to me with your steps written out next Thursday. All right, here we go. So secant of x, I made it too big, didn't I? All right, secant of x minus 1 over secant of x. Which of those does it equal? A, B, C, or D? Doesn't look like any of them, does it? Well, there's special properties, and that's what this section is called, identities. Special properties that allow you to transform that thing into one of those. Well, how do you do that? Well, I'm going to give you some tips, the best I can. There's different things all the time. There's really not one size fits all. There's some creativity here. That's what makes it hard. It's like an art and a science put together. It makes it challenging. Basically, here's the first rule. When I see fractions, like on A, on like number 1 and number 3, is that number 1 and number 3 are fractions? Number 2 is not a fraction. Number 2, there's no fraction. But see how 1 and 3 have fractions in them? When I see fractions, I think right away common denominator. That doesn't always work, but that's usually a good idea. So I'm going to think right away, all right, common denominator. I've got secant, and I'm going to get rid of the x. I know the x is there. I don't care. Secant minus 1 over secant. Let's put those together with a common denominator. That'll probably be a good idea. So let's take that first secant and put it over 1. You know what we do when we have one thing that's a fraction, one thing that's not, put it over 1? And then how do I get common denominator? How do I make their bottoms the same? Top and bottom of the first one by secant, right? The second one's already got secant in his denominator. I don't need to mess with the second one. Everybody good so far? I'm going to move it to a fresh screen so we have room to work here. So this is number 1, secant minus 1 over secant. So I'll put that over 1, multiply top and bottom by secant. What do we get? Secant squared over secant. And the second one hasn't changed. Minus 1 over secant. Good so far? I'm getting rid of the x's. Let's make this simpler.
So would it be 2 secant?
No, secant times secant is secant squared. Yeah, you got to remember from algebra, x times x is x squared. X plus x is 2x. Remember that difference from algebra? When you add things, that's when you, then 2 of them. When you multiply, it's squared. So secant times secant is secant squared. Okay, so now, what am I going to do? Well, I can make them one fraction now. No need to have 2, since they have the same denominator. It's secant squared minus 1 over secant.
Secant squared minus 1 is also the same as tangent.
Nice, exactly. Everybody good to there so far? Now, let me suggest some things that are bad and wrong and you don't want to do. Because this is part of the problem that people get into. They take illegal steps. Not only is it hard to figure out the correct steps, if you're breaking the rules along the way, then you're really going to get in trouble. So let me point out some things I've seen students do over the years that gets them into trouble. Some people think, hey, I'll just cancel one of those secants. You cannot do that. That's illegal procedure. The math cops will come for you. Why? Why can you not cancel there?
Because they're not the same.
Because of the minus sign. Do you know from algebra that when you have pluses and minuses, you may not cancel? You need to know that rule. It comes up a lot. So, for example, if you have x minus 2 over x, it has nothing to do with trig. It's just an algebra rule. You may not cancel those x's. It's illegal. It's false. It's not true. Whereas if you have x times 2, it's totally okay. That one's okay. This one's a no-no. Do you know that rule? You need to if you don't know that rule. Pluses and minuses glue things together, and you cannot break the bond. I always tell my algebra students, it's like shopping in Costco. We have 5 kids. My wife shops at Costco, buys in bulk. You know what I mean? Sam's Club, Costco, you buy in bulk. You go there to grab like one spaghetti sauce off the shelf at Costco. What happens?
You get 2 or 3.
They're like all plastic together, 2 or 3 or 4 of them, right? You can't take your scissors to Costco and just cut it and say, thanks, I just want one. Right? That's the whole deal. You're buying in bulk, get a cheaper deal. So that's what pluses and minuses are like in algebra. Really important rule if you're going to go to pre-calc and calc and on. Super important. It comes up all the time. Think of pluses or minuses like a glue package deal. So whereas times, no big deal. That's just shopping at Save Mart. You can buy just one. You can cancel. No big deal. It's fine. But over here, this x minus 2 is saying, I'm a package deal. You want to cancel me? You go like that and buy the whole package. Otherwise, you don't touch me. I'm all or nothing. You can't have just the x. Pluses and minuses glue things together. Why? Why do we make these hard rules in math? It's just what's true. I can prove it to you with numbers. How about if we take 4 plus 2 over 2? Can I cancel those 2's?
Nope.
You can see that's just not true. That's 6 over 2, really. It's really 3. And if I do that, it's suddenly 4. See how it's just baloney? See that? It's just not true. Whereas, what if it was times? If it was times, would it really be right? It is. Look at it. It's really 8 over 4, isn't it? Is it 4 times 2? 8 over, why did I say 4? 8 over 2. And what is 8 over 2? Really?
4.
4. So was it right to cancel the 2's? Yeah, it's really 4. See how the problem is the plus or minus in the middle? Times, it's fine. That's really 8 over 2, which is really 4. So it's really fine to cancel the 2's. It's really 4. But over here, that's really 6 over 2. That's really 3. It's not 4. Just the truth, huh? Just the truth. So if you come over here and start canceling stuff, that minus is going to haunt you. It's saying, no, no, no. We are Costco shopping. We are glued together. If you want to cancel us, you buy the whole package or nothing, right? So let's go back to it. What was numbers? I've already messed it up. Secant minus 1 over secant. Was that the original problem? And put that over 1. We go back to it again. Secant over secant. So we ended up with secant squared minus 1 over secant. So that's what not to do. Don't do that or the problem's over. You're just lost in the woods without a compass if you do that. So instead, yeah.
Well, how did you cancel the x's then if it's not a package deal? Or wait, it is a package.
So these I canceled because they're not a package.
So like.
Yeah, this is wrong.
No, the original problem.
Why, she's asking why you dropped the X off of secant.
Oh, I'm just being casual. It's really there. I just don't feel like writing everything.
Oh.
Yeah, I'm just, sorry, I'm just being lazy. I just don't want to write everything. It's there.
Because that number could be anything.
Yeah, it could be anything. I just don't want to have too much to write. These take forever anyway. Yeah, no, it's there. It has to stay there. Yeah. Okay, so that's what we can't do that. Well, then what do we do? Well, I need to give you some new rules. That's what Zuhal was mentioning. Let me give you 3 rules. Remember, one of them you already know. Remember, let's keep changing my mind here. Okay, remember sine squared? In fact, let's just go to a fresh screen with those. Well, no, I'll squeeze them in over here. Yeah, sine squared plus cosine squared. Again, I'm not putting the x's. They have x's, whatever. Sine squared plus cosine squared is 1. Do you remember that one? We did that last week, didn't we? Sine squared.
Yeah, it's on my 3x5 card.
That's right, from last week. We didn't hardly. It was on the test though, wasn't it?
I don't think I used it.
I think there was one problem where we had to use it. Yeah.
Maybe I did that wrong.
No, I just gave it to you. You didn't have to remember it. Anyway, sine squared plus cosine squared is 1. Why? I don't want any magic here. Why in the world would that be true? It's actually the simplest thing in the world. Think about the unit circle for a minute. Okay, what is the unit circle? So if you're at any angle, theta, whatever, and you're at some point, what did we define sine and cosine as?
X and Y.
X and Y, right? So we said how far over you are, that's x, that's cosine, right? Cosine, comma sine, didn't we? How far up you are, that's y, right? X is cosine, y is sine. Right? So if you're at any point on a unit circle, how far over you are is cosine, how far up you are is sine, cosine, comma sine, right? That's how we defined it. We just said it will be this way. When you're on a unit circle, remember because originally cosine was x over r, and sine was y over r. But we said when r is 1, radius 1, unit circle, then x over r is just x over 1, it's just x. And y over r is y over 1, it's just y. Remember? That's how cosine became x and sine became y. So unit circle means radius 1 circle. So that means this is 1. It's the radius, right? From the middle to the edge, that's radius of a circle. You go anywhere, you go straight or up or left or down, all those are one. Because they're the radius. Radius is from the center to the edge. Okay, so what? Do you see it now? So if the x is cosine and the y is sine, and this is a right angle, straight over, straight up. Pythag, sine squared plus cosine squared is 1. It's right on the unit circle. It's gotta be. That's where we're getting at. See that? On the unit circle, cosine. So take that cosecant and distribute through the parentheses. You get cosecant times sine plus cosecant times cosine. Good so far? Just take that and distribute through it. Good now? Now what? Any ideas at this point? Think about the different things we've done. What might be a good idea at this point? Shall we go with the clearance plan?
No,
What am I meaning? What did Clarence suggest last time? Break it into sines and cosines. Exactly. That's often what we do. So take that cosecant. Remember what he's the opposite of? Take that cosecant and write him as what he's. You need to know those, or have them on your 2x5 card. It'd be best if you just know them cold. What is cosecant the upside down of? Sine. So rewrite cosecant as 1 over sine. Both those cosecants, rewrite them as 1 over sine. That's often what we do, as Clarence pointed out. We rewrite things in terms of sine and cosine. So this cosecant is 1 over sine. And this cosecant is 1 over sine. Good to there so far? You're looking at the options? You always want to kind of keep one eye on your work and one eye on the options until things start to match up. As soon as you can see it, grab it. As soon as you're sure. What is 1 over sine times sine? Yeah, because this is over 1, right? Remember, anything that's not a fraction is really over 1. It's really in the top, isn't it? So that'll cross cancel, won't it? So this is just 1. Good so far? And now let's do the same thing with the cosine. This is cosine over 1. So if I put those back together, it's cosine over sine, which is on our sheet. There it is. It's B. Everybody see that? That one's a little easier, right? They're not all as bad as that first one. Some are worse. No, not much worse. Is that good? Have time for one more? Should we try number 3? I already told you the strategy for starting number 3. What do you do when you got fractions? Common denominator. I think common denominator would be a good plan. Oh yeah, it will be. Yeah, that'll do it. So number 3. Sine over cosine. That's cosine over sine. So we're adding those up. Get a common denominator. Make both denominators become sine cosine. Right?
Mr. Aaron? So, couldn't we, this is tangent and this is cotangent.
It is. But the problem is that's just not there. See, that's what the problem is. There's a lot of true things that are just bad directions. Even though that's true, that's just not where they happen to go. That's why these are creative. I mean, and another problem, if that's one of the options, boom, you're done. Because you're right. That's a good observation. It's just not where they happen to go. As you look at those options, it's not there.
So it's kind of like those puzzles where they give you a starting point and an ending point, and you have to figure out how to get from
Yeah, that's
A to
it.
point B,
They picked the ending point, and we've got to see,
how to get there.
yeah, well, they got 4 ending points. Which one's a real possible ending point? Yeah. All right, we good? So I'm going to do common denominator. So I'm going to multiply top and bottom of this one by sine, top and bottom of that one by cosine on number 3. Does everybody see that? Do you see why I'm doing that? Because I'm going to make both denominators be sine cosine, aren't I? See how both denominators will become the same, common? Sine cosine? Okay, so then what do we have at that point? We have sine squared over sine cosine plus cosine squared over sine cosine, huh? Yeah. Do you see that? Yeah, put it together. That's sine squared plus cosine squared over sine cosine. That's 1 over sine cosine, right? The Pythagorean identity, sine squared plus cosine squared is 1. That'll come up a lot. Sine squared plus cosine squared is 1. When you see that happen, you think, oh, I've got to be on the right track. Something good's happening here. All right? But we're still not there. You say, that's it. I'm going to look for it. It's not there. It's not there. But you're just one step away. What could we do? As you look at this list, what could you do? This is where it's creative. I mean, they could have put that there. They did it. What could we do? Flip it? Well, it is secant and cosecant. We can't flip something. It already is. And I think I know what you're saying. Let me say it this way. You're totally right. That's exactly what we need. It already is that. You know what I mean? I'm just saying you don't want to say it that way. Like you can't just flip something over. That's illegal. But I know what you mean. I know what you mean. You're saying. I'm sorry. I'm just being picky on the words. You're right. What is? So everybody agree that this is this. I just kind of separated them, right? 1 times 1 is 1, and sine times cosine. And what is 1 over sine? Yeah, what is it the flip of? Cosecant. That's cosecant. You need to know those well. You really do. If you don't know those, you're going to have trouble, because that's part of the thing, is they kind of be in your mind. Because you're trying to, when you look at something, you go, oh, I know. Boom. If they're all just on your paper, it's going to be hard to make the connection. So you need to know 1 over sine is cosecant. That needs to be pretty much cold knowledge. And 1 over cosine is secant. And that's exactly right. There it is. Leanna's right. And that's on our sheet. That's D, huh? Secant, cosecant. It's the other order, but order doesn't matter. Secant, cosecant. You see it? All right, we did 3 out of 18. So, that's a little bit.